Welcome back. In this lesson, we're going to look at the development of a stream valley. So if you have a very steep hill and water's flowing across that hill, it's going to go very fast. And that speed of that water has enough energy to carve deep into the ground. And so you end up with a very steep-sided V-shaped valley. If you have a river system that's not flowing in the mountains and it's a very flat area and it's getting flatter and flatter as it heads to the ocean or wherever it's flowing to, normally the water then would cut along the sides of the streams and you end up with carvings and meanders and turns in a river. And we'll see that the shape of the topography of the land has a lot to do with the speed of the water. So let's look at some of the examples. So I suppose you know what a valley is. Okay, a valley is a dip between two hills. A lot of times, though, the valley has been caused by the river itself, and the hills used to be a flat plain. Now, it's not every case, but a lot of times the river is actually carving into the hillside and making the hills steeper or making the valleys wider, etc. So the valley is not just the channel where the river is, but it's also any of the surrounding hillside that's dumping water into the stream. Okay, so you've got a couple different shapes depending on how steep it is. If you have very steep mountain, then the water is going to be falling very fast. And as it falls, it has such speed that it can cut into the rock and to the soil that it's sitting in. So instead of cutting sideways and making the valley wider, it's cutting down and making the valley deeper. And so you end up with a gorge. And normally a gorge is going to have a very steep-sided hill with softish rock that the water, because of its speed, is able to cut into. Now, once it's not as steep, once a river is less steep, it's going to travel much slower. And as it travels much slower, it's not going to cut so much into the down as it cuts sideways. So as it bumps into the sides of the channel, it'll scrape the soil that's on that side or this side, and you end up getting turns or curves or waves, or they're called meanders, in a river or a stream bank. And so you'll end up with a wider valley. So you either have narrow V-shaped valleys in the real steep terrain, or wide valleys, flat-floored wide valleys where the river kind of goes back and forth as it's cutting sideways into the soil. All the streams eventually will follow their channel until they come to a place where they empty into a larger body of water. So a stream can empty into a river, or a river can empty into a lake, or a river can empty into the ocean. Sea level is that lowest level that water flows because it's kind of the zero mark worldwide. Any topography, land, height of the land is always measured against sea level, so water is always going to flow down into the sea. So you can have temporary base levels, like if it's dumping into a lake. So Summit Lake, which is on top of the hill, you actually have a lake up there. Any streams above that lake would dump into the lake, but normally you consider ocean or the sea as your base level. Now, interestingly, some interesting things happen to streams when the ground underneath of them move. So if you were to have a fault line where you're actually going to have a huge crack in between two parts of a landmass, and the landmass shifts. So what's happened is either one side has actually lifted, you get a rising up, or the other side has dropped. So you've got a huge crack in a rock, and you've got movement and adjustment in as it's trying to alleviate the pressures that it's under. And what happens is if you have a flowing stream on top of that, you may end up with a very serious change. You'll end up with a waterfall. So for instance, if you have a cliff right in the middle of a stream, you're going to end up with a waterfall. Now that waterfall is moving water and can cut into the rock. It depends on what the rocks are made out of. If you have very soft rocks, then eventually that stream is going to carve all those rocks down. And over time, you'll end up with a nice smooth slope where you wouldn't even be able to tell that there had been a cliff raised. But if you have hard rock, your layers of hard rock inside the uplifted region, then it will carve slowly, or it'll carve in weird shapes, and you'll end up with horseshoe curves. A lot of times, big sets of waterfalls are like this. So the Niagara River, Niagara Falls, you end up with a big horseshoe curve falls as it's cutting into the more resistant rock that's underneath it in a different amount of time. So some things are eaten away quicker than others, and you end up with different shapes. If you had no resistant rock layers, then it basically over time will smooth out, and you get a nice hillside like you may have had originally. All of that material would simply be eroded away. Now, the steepness of the terrain also will determine how fast the water moves. The steeper it's falling downhill, the more energy that it has, the more potential and energy it has, and its rate, so the amount of power that it actually has. So falling water has a lot of power. You can make electricity with it. So when you have steep terrain and water is rushing along it, it's going to cut very, very deep rather than cutting sideways. So you're not going to have a broad valley. You're going to have a very narrow valley, and your narrow valley is going to be like a V-shaped valley. So you can have lots of waterfalls in this. There's all kinds of rivers around here like that, where you have waterfalls or you'll have rapids. It depends on how much water is rushing and the gradient, how steep that river or stream is. So the closer that a stream or river is to reaching its base level, say the ocean, normally the less steep that the terrain is. And as it goes less and less steep, the river, first of all, becomes flatter, and it doesn't cut down into the rock as fast because it's not moving as fast. So you end up with a flat place where the river is kind of winding back and forth, and this is called a floodplain. So the river can be as wide as all of those curves are if there's huge amounts of water coming across the river, or they simply cut along the meanders as it goes back and forth if there's just a small amount of water in it. So the meanders are these curves, and they kind of cut along the sides. So the water, as it's coming into a curve, whatever side of the stream is moving a little bit faster, so the outside curve is going to be moving faster, you're going to get a cutting into that outside curve. And so normally it's going to cut along so if it's turning left, it'll cut into the right bank because that's where the fast water is. The slow water is going to move on the left, and you'll end up with deposits. Okay, as the river loses speed, it starts dumping the material that it's holding, the rocks, the stone, the sand, the gravel, whatever, and it dumps along the slow side and then cuts along the fast side. So what happens is these meanders will get more severe. So instead of little winds, you end up with really, really big ribbons of back and forth movement in a river, and then all of that side has been cut, and so you end up with a flat area that river's flowing in, and that's called a floodplain. So this should exemplify that and help you to see what we just talked about. When you have a steep-sided valley, the water, especially if it's a steep river, the water's going to move very fast, and you're going to cut very deep, and you get V-shaped valleys. As soon as it tuckers out, and most of that material is gone, then it's not so steep anymore. Then you're going to have kind of a wide valley where the river is meandering back and forth in curves, and it cuts along the outside edge as it's flowing, and so the erosion is going to cut into the surrounding rock on the sides, and then the valley gets wider and wider and wider, and that flat-floored valley is called a floodplain. And in the event of a flood, the flood would extend over that entire plain, and in that entire plain would be something like a big riverbank. But if there's not a lot of water in that river, then it'll follow the small meanders that it's cutting down into it.